Section 5.4, Comparing and Graphing Ratios. Today our objective is that you can compare and graph ratios. So at this point we have become proficient with writing ratios, writing equivalent ratios, using ratio tables, but at this point now we need to be able to use that information from a ratio table to graph these ratios and then compare them using the visual aid of the graph. So let's talk about some important vocabulary. Comparing ratios. To closely examine the relationship between two or more ratios in order to make inferences about the ratios. Okay? So that is why we compare ratios. When they are two really close ratios, we want to examine the relationship between them. For example, if it takes Juan 15 minutes to run 2.5 miles and 40 minutes to run 5 miles, we have a rate of 15 minutes to 2.5 miles and a rate of 40 minutes for 5 miles. Each of those respectively make a unit rate of 6 minutes per mile and 8 minutes per mile. So we can compare those ratios by examining the unit rate of each. Okay, what does it mean to make an inference? Well, in language arts, I'm sure you've talked about inferences before. An inference is a conclusion that is reached on the basis of evidence and reasoning. So, for example, based on Juan's running rates and unit rate up above, we can infer that the longer Juan runs, the slower his pace is. We can also infer that Juan runs faster when running short distances. All of that can be gathered because of the comparison of the rate and the unit rate of the two different timed runs. So procedures for comparing and graphing ratios. First, we need to organize the given data into ratio tables. Second, fill in any missing data using the procedure learned in lesson 5.2. So if there's anything missing in a ratio table, we need to be able to fill those missing spaces in to make each ratio equivalent. Okay, third, graph the data onto a coordinate plane. We will discuss that here in a minute. And then identify the ordered pairs found within the ratio tables. The values in column 1 are the x coordinates, and the values in column 2 are the y coordinates. So if we have a ratio table, the values in the first column over here will be your x values, and the values on this side will be your y values. If your table goes sideways, then you may have your x value on top and your y value on bottom. Then it says the pair of values in each row forms the ordered pair. So for example, if we have our table that looks like this, each row, the values in this row will make up your ordered pair, your x and your y, that will be graphed. Locate and graph each ordered pair onto the coordinate plane. Connect the graphed points for each data set from each table. Carefully study the graph to make inferences about the data. So, what does all this mean? Let's give it a try. If a hot air balloon rises 9 meters every 3 seconds, and a blimp rises 7 meters every 2 seconds. So complete the ratio table for each aircraft. So First, we have two ratio tables. And the first thing that it told us that we needed to do in the notes was to complete the ratio table. So in this case, we have a ratio of 3 to 9, 6 to 18. Now we need to complete the rest of the table. How is it that we get from 3 to 9? Well, we multiply by 3. So 9 times 3 is 27. How do we get from 3 to 12? We multiply by 4, so 9 times 4 is 36. What about the blimp? Well, their time on the blimp is that the blimp rises 7 meters every 2 seconds. So we have the time is 2 seconds, the height is 7 meters. As it increases, this side is increasing by 2, this side is increasing by 7s. And they are just skip counting, but remember, you can always look to see, okay, how do we get from 2 to 6? It's multiplying by 3. So we also need to multiply the 7 by 3 to get 21. How do we get from 2 to 8? Multiply by 4. 7 times 4 is 28. Now that we've completed our table, it says, graph the ordered pairs. Remember, the first column is your x-axis, the second column is your y-axis. X, y. So on a coordinate plane, remember, our x-axis is always the horizontal line, and the y-axis is always my vertical line. Right here is my origin. Okay, remember, a coordinate plane has 4 quadrants. Okay, this is just quadrant number 1. So this is the ordered pair 0, 0. And anytime we plot a point on our graph, remember, the x-axis, in this case, it's saying that in this particular graph, we have one of our units that we are going to count by 1s, and then the other we are going to count by 4s because of the limited amount of space in our graph. So on this side, we're going to count by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and on this side, the y-axis, it says we're going to count by 4s because the numbers get much bigger. So we're going to count by 4s. 4, 8, then 12, 16, 20, 24, 28, 32, 36, 40. So if we want to graph these points, remember the x always goes first, that's my left and right, and then my y. So if I want to plot these points, the first one we have the point 3, so over right 3, and then up 9. Well, 9 is not on one of the lines, it's going to be right above the number 8, so somewhere right there. Then we have 6, 18, so over 6 up to 18, right in the middle, right here, in between 16 and 20. Then 9 and 27. 27 is going to be right underneath 28. And then 12 and 36, all the way up to 36, right on the line. So one of my graphs for the balloon, my line, now I will connect the dots, looks like this. Okay, now I need to do the blimp. I'm going to do the blimp in a different color for you so you can see it. So we have 2, 7. Then we have 4 and 14. And then we have 6 and 21. And then 8 and 28. So this line is going like this up my graph. So now, what can you conclude from this graph, and which aircraft rises faster. So from this graph, we can conclude that as more time passes, which balloon is rising faster? Well, we can tell from our colors here that the second one, the blimp, is rising at a faster rate. The blimp rises faster. And we can also conclude that the balloon rises slower. Okay, so which aircraft rises faster? We know that it is the blimp, because we can clearly see that the blimp's line is going higher. Okay, I would like you to now pause and try one on your own. Okay, remember, in this case, it says an eagle eats about 1 pound of food in 1 day. A crow eats about 3 pounds of food in 2 days. So here are the two different ratio tables of how much an eagle eats and how much a crow eats. We're going to compare these two using a graph. So first you need to complete your ratio table. After completing your ratio table, remember that this is your x, this is your y. This is your x, this is your y. Your graph looks plenty big. A suggestion is given down here in section B that you will number both the x-axis and the y-axis by ones. So in this graph, you're going to number this. This is 0, or 0, 0. Okay, this is going to be 1, 2, 3, 4, 5, counting by ones and so on. This will be 1, 2, 3, 4, 5, and so on. Okay, so go ahead and complete your table. Then graph your points on the graph, and then you need to make a conclusion. What can you conclude based on the graph and the tables, and which bird eats more per day? Okay, go ahead and finish your pause and try, and we will check these together in a few minutes. If you finish early, go ahead and work on Khan Academy.